As you can see over here, this is a video related to environmental chemistry part 4, where we will be discussing about oxides of nitrogen. Okay, we are already gone for 3 previous ones as well, which consisted of carbon monoxide, carbon dioxide, and oxides of sulfur, right? I hope you have gone through it. If you haven't, then please go through it and then refer this part 4. If you want, I can give you the link of the video of the previous 3 as well, if you can go through the description box in this video. All right, so we start off with. We are now going to discuss about oxides of nitrogen, how it is responsible for environmental pollution. So we begin with the first point, and that is about the sources of emission. The first one is by natural synthesis, which involves formation of nitric oxide by natural synthesis. Now, when I talk about natural synthesis, that means I'm talking about lightning and thunderstorms. So during that, there's going to be a high temperature being created, and the nitrogen and the oxygen present in the atmosphere results in the formation of nitric oxide. Next, this nitric oxide form undergoes oxidation, obviously in presence of oxygen, resulting in the formation of nitrogen dioxide. So this is, my dear friends, natural synthesis as far as the sources of emission of nitric oxide is concerned. Also, one more important thing which I would like you to understand, and that is that oxides of nitrogen, when we consider, nitrogen forms oxides corresponding to the various oxidation states from +1 to +5 as nitrous oxide, nitric oxide, dinitrogen trioxide, nitrogen dioxide, and nitrogen pentoxide. But out of which nitric oxide, formula NO, and nitrogen dioxide, formula NO2, these are the main pollutants which are present in appreciable quantities in the air. All right, so this is just for your information. We go to the next part, and that is, what are the other sources apart from the natural sources as far as emission of oxides of nitrogen is concerned? Here we go. First one is we talk about aeronautics. So that means we talk about aeroplanes and the space aircrafts and space missiles and etc. etc. Next is we talk about power plants which are going to employ fossil fuels. So fossil fuels on combustion results in the formation of oxides of nitrogen. Then we go into automobiles. The exhausts which are coming out of the automobiles do contain in some amount oxides of nitrogen. And also we have industries which produces nitric acid, that is HNO3. Now, during the formation of nitric acid, sometimes the oxides of nitrogen are also going to be formed, or it also happens many times that the oxides of nitrogen which we use as a raw material is not being completely converted into nitric acid, and as a result of which it is being let into the atmosphere. So these are some of the other sources which we can also categorize as man-made sources: aeronautics, power plants, employing fossil fuels, automobiles, and of course, as I said, nitric acid producing industries. Now, please be very clear, and that is, when you talk about fuel combustion, now the sources from the fuel combustion produces about 10 million tons of nitrogen oxides. Now, out of which 1/4, that is around 25%, is generated from electrical sources, 17% are from industries, 9% are the domestic sources responsible for that, 46% is from transportation, and approximately around 3% is going to be contributed from commercial operations. So these are the various sources from which the oxides of nitrogen are emitted into the atmosphere. Now we talk about the reactions involved. Now in this case, we are going to consider the formation of nitric acid as the final product. Now, how that nitric acid is going to be formed? In the first step, nitric oxide undergoes oxidation, resulting in the formation of nitrogen dioxide. Step number 2, nitrogen dioxide is treated with water, resulting in the formation of nitric acid, and nitric oxide gas is emitted. The other way, my dear friends, and that is the nitrogen dioxide, which is formed in step number 1, undergoes hydrolysis as well as air oxidation, resulting in the formation of nitric acid. Now, this nitric acid, my dear friends, acts as a temporary reservoir or a temporary accumulation. And it comes down in the form of acid rain, or it is being precipitated in the form of nitrate salts. Acid rain can lower the pH of rainwater, and it goes down to 4 or 5. Generally, when you talk about the pH of rainwater, it's somewhere around 5.6 to 5.7. It is in that range. But now, when the acid rain concept is being considered, the nitric acid is going to mix with the rainwater, and as a result of which, the pH substantially drops down. And as you know, that lower the pH, greater is the acidity, and hence we term this as acid rain. It also affects the vegetation, the building materials. Okay, that means it is in the form of cracks or corrosion. And some species, or like say water, fish, etc., gets affected. Nitric oxide can also reduce the transport efficiency of hemoglobin. Now, here let me just give you some detail about it, and that is the oxygen which is present, okay, in our body will combine with hemoglobin, resulting in the formation of oxyhemoglobin. Okay, and through the blood, the oxyhemoglobin reaches to the various cells of the body, and once it reaches, it undergoes dissociation into hemoglobin and oxygen, and as a result of which, the cells are getting oxygen. So this is what the transportation of oxygen is all about, and that is going to be hampered if there is considerable increase in the concentration of nitric oxide in the blood. We now go into health hazards. Here we have the various health hazards. The lower concentration of exposure, it results in irritation of the eyes, throat, as well as lungs. It does attack the mucous inner lining of the lungs. Acute symptoms like emphysema are being caused on continuous exposure to levels of somewhere around 10 to 40 parts per million. Higher concentration can also cause photochemical smog. We'll be talking about that in the later part of this video. Continuous exposure for an hour to a lower concentration will bring about changes in the airway resistance in asthmatic patients. Now, when you talk about asthma, it's about a disease whereby the person is unable to breathe in a normal way. So there is some going to be resistance. There is going to be some blockage as far as the breathing lineup is concerned. Now, this is going to make it more adverse as the oxides of nitrogen concentration is going to increase. So these are some of the health hazards associated with the oxides of nitrogen. Now, we talk about photochemical smog. Now, photochemical smog is associated with a photolytic cycle. Now, what is a photolytic cycle? That I'll try to make you understand this. Now, see, first of all is smog. When you use this word, S-M-O-G, it's a combination of smoke and fog. You know what is a fog is? It's a phenomenon whereby the visibility is reduced. And if you add smoke into that, the situation is going to become still more worst. So that is what smog is all about. Now, because the word is photochemical, so that means it is a reaction which is taking place in presence of sunlight, in presence of oxygen, and therefore we call it as photochemical smog. A chemical reaction taking place in presence of light. Okay, so breakdown of certain molecules, and therefore we call this as photolytic cycle. So here in this case, photochemical smog in a higher concentration is going to be responsible for as a primary pollutant, strong sunlight, and a stable air mass. Okay, so these are the contributors for photochemical smog. Now, how exactly this entire process takes place? Nitrogen dioxide absorbs the ultraviolet rays, that is the UV rays, and it results in photochemical decomposition. That's what we call it as photolysis. So you can see the reaction. NO2 breaks down into NO plus nascent oxygen. This nascent oxygen is unstable, and hence it has got a higher amount of energy. Now, this reaction takes place at a wavelength range of around 300 to 400 nanometers. Okay, because that is going to be the wavelength region of ultraviolet rays. Now, in the next step, the atmospheric oxygen is going to combine with the unstable, the nascent atomic oxygen, resulting in the formation of ozone. Ozone then reacts with nitric oxide, resulting in the formation of nitrogen dioxide and oxygen again. And in this way, it completes the atmospheric nitrogen dioxide photolytic cycle. If you can see this reaction, a chain of reaction it is, we started with NO2 and we are getting NO2 back. And that's why we use the word cycle. Okay, so I hope you have understood the entire series of reactions. And I hope you have understood why we call this as a photolytic cycle. Now, we talk about some adverse effects of the photochemical smog. Now, during the daytime, the concentration of ozone increases. The oxygen from the ozone attacks the hydrocarbons, which are going to be emitted from the exhaust of the automobile. Now, this results in the formation of a very toxic compound. Of course, a series of reactions do take place in this, and the toxic chemical compound which is going to be formed is known as peroxyacetyl nitrate, or which is being called as PAN, PAN. As I said, PAN is toxic, highly dangerous pollutant. It causes mental tension, eye irritation, and it also results in loss of hair. Now, during the nighttime, it's being observed that the concentration of nitrogen dioxide increases. And as you can see in the photolytic cycle also, which I explained you, the nitrogen dioxide is the starting material for this entire cycle to be completed. So as you can see, during the daytime as well as during the nighttime, okay, both of which are going to be responsible for this photochemical smog. And one of the chief contributor for the photochemical smog, yes, of course, is oxide of nitrogen. So I hope the concept is clear. So my dear friends, on the basis of the discussion, what is being done so far, you have all realized that oxide of nitrogen is not good enough, not for human beings, not for vegetation, not for architectural purposes, also not for aquatic plants and animals. So it's obvious when it is not good enough, when it is going to be toxic, when it's going to be hazardous. So obviously we have to seriously think about the control measures. Now, my dear friends, when you talk about the control measures, what is our line of action is? The method of controlling oxides of nitrogen as a pollutant primarily depends on three factors. The first one is reduction of availability of oxygen during combustion. Okay, because oxygen is one of the culprit, I can say over here, because it combines with nitrogen, resulting in the formation of what? Oxides of nitrogen. So we need to make sure that the oxygen which is required for combustion is just sufficient for that process to take place. Anything excess of oxygen available will react with the nitrogen, resulting in the formation of oxide of nitrogen. We need to design the combustion equipment in such a way so as to reduce the peak temperature. Because see, as I said, the combustion of nitrogen doesn't take place at room temperature. It's because of the inert character of nitrogen. Because when you talk about N2 nitrogen, between the two nitrogen, there exists triple bond. And hence, for the formation of an oxide of nitrogen, all three bonds needs to be broken. And for that purpose, high amount of energy is required. So therefore, the oxides of nitrogen are going to be produced at a high temperature. So what we do is that suppose if there is an availability of nitrogen and also oxygen, but then somehow or the other, if we make sure that the required temperature is not available, then in spite of the availability of nitrogen oxygen, they will not react with each other. And as a result of which, the concentration of oxides of nitrogen can be considerably reduced. And the third one, my dear friends, is about reduction as far as the residence time at the peak temperature is concerned. Okay, residence time is the time which is being required for the existence of the particular species. So if you reduce the time, so it's very obviously that particular species is not going to exist for a longer period of time, and the species which doesn't exist for a longer period of time are going to be considered as what? Unstable. And if their existence itself is very much in danger, since very obvious is hazardous effects will be minimized to a considerable extent. So this is, my dear friends, about the three different aspects which we need to consider the control measures of oxides of nitrogen. Now, the various methods that are being used that will follow this particular guideline, and that is here we go. These are the methodologies, my dear friends, of the control measures. Of course, all of which are going to follow the principles, the bases, the three bases, or the three principles which I just explained you. So the first method is low excess air combustion. So that means for a combustion process, we require oxygen. So we make sure that the amount of oxygen is such so as to ensure complete combustion of fuel. So there is no excess of oxygen available for the reaction with nitrogen, resulting in the formation of nitric oxide. Next is modification of burner design. Now, in the power plants, it has been found that if we bring about some modifications in the design of the burner, then the emissions of oxide of nitrogen can be minimized. And how it can be done is, and that is, the burners are located in the corners of the boiler in a tangential firing. Okay, rather than exactly keeping it below, okay, it is going to be tangential. So as a result of which, what happens is the peak temperature is reduced. And if the peak temperature is reduced, then as I said earlier, it will contribute towards the reduction of the emission of oxide of nitrogen. Next thing is we have EMTR technique. Now the exhaust of automobile is going to be provided with this particular technique so as to decrease the emission of oxide of nitrogen. Now what is EMTR stands for? My dear friends, it stands for exhaust manifold thermal reactor. It is a device which is being based on air injection principle, and as a result of which the availability of oxygen with nitrogen is being decreased to a considerable extent, and also the temperature is reduced. And as a result of which, the combined effect of this is the emission of oxide of nitrogen is reduced. We go into two-stage combustion. Now, in two-stage combustion, what we do is, as the name suggests, we are not going to carry out the combustion process in one step. The reason is because if we want to carry out the combustion process in one step, then what happens is that we need to supply a greater amount of oxygen, and at the same time, the high temperature also has to be provided. And this is responsible for the emission of oxide of nitrogen. So what we do is we carry out the combustion in two steps. So when we carry out in two steps, so what is happening is the peak temperature is being reduced. And as I said, if the peak temperature is reduced, the probability of combining the nitrogen and oxygen together reduces to a greater extent. Now, the burners are so designed that around 95% of the stoichiometric air is going to be directed at the burner. The remaining 5% of the air is supplied in the second stage of combustion. Now, if we are going to carry out this control technique, then it has been observed that nearly 35% of emission of nitric oxide is reduced. How much? Nearly 35% is reduced by carrying out this two-stage combustion. In the first stage, around 95% of the air is directed, and in the second stage, 5%. Okay. The last one is fuel gas recirculation. As the name suggests, the fuel gas is recirculated once again back to the combustion chamber. So when recirculated fuel gas is being used, so it's very obvious it is deficient in oxygen. And as a result of which, it also minimizes the peak temperature. So there is deficiency of oxygen, and also the peak temperature is minimized. And as a result of which, the formation of oxide of nitrogen is reduced to nearly 90%. Yes, my dear friends, you heard it right. Its reduction is being done by nearly 90%, 90, in gas-fired boilers. So in this way, we can considerably reduce the emission of oxides of nitrogen. So this is, my dear friends, about the control measures with respect to oxides of nitrogen. So I hope, my dear friends, you have understood this concept very well, where we first of all took into consideration about the sources, the natural sources, as well as the man-made sources. Then I also told you about the chief sources in terms of percentage. Then we talked about the reactions and the fate, the health hazards. Specific reference was being done to photochemical smog. And at the end, we discussed about the control techniques. So I hope you have clearly understood the oxides of nitrogen and its role, which is being played is as far as environmental pollution is concerned. So thank you very much for being with me. I'll see you next time with another topic of my video. Thank you very much. Take care.